When we look at a shape, we can ask three different questions. How long is its edge? How much flat space does it take up? And how much space does it fill in 3 dimensions? Perimeter is just the outside path, like a fence around a yard. Area tells us how much flat space is inside that boundary. You can think of it like tiles on a floor. And when we give a shape depth, we get volume, the measure of 3-dimensional space that the object fills. Let's start with perimeter. It's simply the total distance around a shape. For a triangle, we add the lengths of all 3 sides, A plus B plus C. For a square, it's even easier. Since all 4 sides are the same, we can just multiply the length of one side by 4. But what about a circle? A circle has no straight edges. That's why we use a special formula with the radius r and a very special number. The circumference of a circle is 2 times pi times r. But wait, what exactly is pi? Imagine a circle with a diameter of exactly 1. If we roll that circle and unroll its circumference along a straight line, we'll see it stops at a value just over 3. More precisely, at about 3.14. This magical ratio between the circumference and the diameter is always the same for every single circle in the universe, and that's what we call the number pi. Now let's move on to area. Here we count how many square units fit inside the shape. For a square, we simply multiply the side by itself. For a rectangle, we multiply the length by the width. Think of it as counting rows and columns. And a triangle? Notice how every triangle is actually exactly half of a corresponding rectangle. That's why we calculate its area by multiplying the base and the height, and then dividing that result by 2. So how do we calculate the area of a circle when it has no straight edges? We'll use a visual trick. If we slice the circle into many thin wedges and rearrange those wedges, they start to form a shape that looks a lot like a rectangle. The width of this new shape is half of the circle's circumference, which is pi times r, and the height is the radius r itself. When we multiply those, we get the famous formula. The area of a circle is pi times r squared. Before we jump into volume, we need to clarify one more thing: surface area. 3-dimensional objects also have an area. It's their outer shell. If we unfold this box, we see that it's made up of 6 flat rectangles. The surface area is simply the sum of all these outer faces. We still measure it in square units because we're only measuring the shell, not the space inside. Finally, volume. Here we measure how much space an object fills by counting cubic units. For a cube, we multiply its 3 equal dimensions. For a prism, the idea is simple. First, we calculate the area of the flat base, and then we stack that base layer by layer through the entire height. So, base times height. The exact same rule applies to a cylinder. The area of the circular base multiplied by the height of the cylinder. But what about pointy shapes like a pyramid and a cone? For them, the brilliant 1/3 rule applies. It takes exactly 3 of these shapes to fill one prism or cylinder with the same base and height. That's why the formula for their volume is the same, just multiplied by 1/3.